and then the name of the image. So this is the Python image. And then if we want to, we can also do a version. So I'm going to do 3.9.7. And if you're wondering where I'm getting this from, this is all from the documentation. You just say from the name of the image, which in this case is Python, and then you could see the different tags. So if you want 3.9.7, slim, bullseye, that you got that. And if you want to see them going over that in an example, we're kind of basically just following this essentially. The next step is going to be an optional step, but I always like to do this. We're going to use the workdir flag, and this is going to set the working directory. So I'm going to say this is going to be user source /app. Now, how do I know that there's a folder called user/source? I've actually run the Python image myself, and I checked to see where I could actually set up my application. So I found that there is a path here, and then I want to create a folder called app, and this is where I'm going to store all of my application code. And once again, you can take a look at the documentation, and it does the same thing. So if you're ever lost, just take a look at the doc, and it's going to help explain things. But like I said, this is the optional command in this case, because what it really does is it's going to tell Docker, this is where all of the commands are going to essentially run from. So it's like doing a CD into /user/source/app, and then anytime we give it any instructions, it's always going to do everything in that directory. So it's just going to help simplify some of the later steps, but it is technically optional. The next thing that I want to do is I want to copy our requirements.txt file from our local machine onto our Docker container. So we use the copy command, and we say we want to copy requirements.txt, and then we have to specify the directory within our container or image that we want to copy it to. So I'm going to say /. So where does this exactly point to? Well, remember, we set our working directory. So everything is going to be with regards to that directory. So when I say the current directory, that means this directory. Now, if we didn't have this line right here, then we would have to specify the full path to that directory. So you can see that it's kind of simplifying things for us, because then we can just kind of say, hey, I want to use the current directory because that's what the working directory is. And the next thing that I want to do is run a command, which is going to be responsible for installing all of our dependencies, because we have our requirements.txt file copied into our Docker container. So we're going to do pip install the -r and then requirements.txt. And if you want to, we could also specify the --no -cache -dir if you wanted to as well. And so that's going to install all of our dependencies. Then the next thing that I'm going to do is I'm going to do copy ... So what does this mean? This is going to copy everything in our current directory, so all of our source code, and then it's going to copy it into the current directory in our container. So what is the current directory? Well, that's the one that's set by workdir. And once again, if we don't have this defined, then we would have to specify the full path of /user/source/app. Now, one thing that you might notice that's a little unusual is the fact that we copy all of our source code at the end right here, which is going to include everything in our directory, including the requirements.txt file. So you might be wondering, well, why exactly do we copy just the requirements.txt file up here? Well, this is a little bit of an optimization that Docker provides us. So when Docker runs, when we build images from a Docker file, it actually treats each one of these lines or steps as a layer of the image. So it kind of builds an image by running the first layer, then creating the second layer, the third, fourth, and fifth layer. And it actually caches the result of each step. So this is important because when you cache the result, if nothing changes, then we can just use the cache result. So let's say I, run this image, or I create an image from this file. It's going to take a certain amount of time because it has to do a pip install requirements.txt, where it's installing all of the dependencies, which does take a decent amount of time. But if I run this again, right, and nothing changes, well, then it can just use the cache result because it knows nothing's changed. And this is important because when I change my source code here, maybe like my database.py file, it's going to see what steps changed, right? And so if I change my source code, does that change the base image? No, we're still using the same base image. Does it change the working directory that we used? Nope, still the same. Did it change the requirements.txt file? Nope, still the same. Did it change any of the dependencies that we installed? Absolutely not. It only changed the final step. So this causes Docker to be able to use the cached result of step 1, 2, 3, 4 of step 4, and it only has to rerun step 5. But if we change requirements.txt, this file right here, then it knows that this step changed here. So it's going to have to rerun this step, then this step, then this step. Right? And so this gives us an advantage because anytime we change our source code, we only have to run this last step. And if we change our requirements.txt, then we have to run all of these steps. And keep in mind that this step is the longest step. And so if I had actually, if I can comment this out. So if I didn't have this line and instead I copied all of my source code right here, what would happen is every time I changed any code in any of my files, I would have to rerun a pip install every single time. And that would cause us to have to rerun the longest step in our build process. And so that's why we have this optimization. That's why we copy the requirements.txt file so that we can cache that result. And so anytime we make any changes to that file, anytime we make any changes to our source code that's not in that file, we don't have to rerun a pip install. All right, and then finally, we have to give it the command that we want to run when we start the container. So we'll say cmd brackets. And so the command that we want to run is uvcorn app.main app. And so the way we actually specify the command is we break out each word of the command. So here we do uvcorn, and then we say app.main app. And then here we're going to pass in the host flag and the port flag like we did on our Ubuntu machine. So we do --host 000, and then we do --port. And that's going to be 8,000. Okay, so it's basically anytime you have a space between the commands, you just split it up into a different string within this list. That's just kind of the syntax that you have to use with these Docker files. But it's the same thing as running uvcorn app.main app and then --host --port 8,000. Oops, 8,000. So it's just going to essentially run this in our container. We just have to provide it in this format. All right, and so now our Docker file is complete and we can actually build our image. So what we're going to do is I'm going to do a Docker, and then the command to build our image is build, and then we'll do a --help so we can see all of the different flags. And most of these don't really matter. The only one I really care about is a tag. So I want to give this a name. So I'm going to say Docker build -t. I'm going to give this image a name that I think is reasonable. I'm just going to call this fast API. And we have to pass in one last argument, which I forgot, which is going to be the context. You could think of the context as just kind of the directory where the Docker file is. So it's going to be in the current directory because we can see the Docker file is in the root of our folder structure. So I could just say dot. And so now it's actually going to build our image. And if I do a Docker image ls, we can see all of our Docker images, and you'll see that I've got a whole bunch, but we've got my fast API right up here. And so now we can go ahead and use this image for actually building out a container. And we can run a whole bunch of Docker commands like docker run, and then specify the image that you want to use, and then pass in all the flags. But I don't like doing that. I don't like working with Docker run. Instead, I want to use Docker Compose. And if you have never worked with Docker Compose, it does the same thing as running Docker commands on the CLI. We just provide all the instructions on a file so that we don't have to remember all of these long commands with all of these extra flags. We literally write out the flags in a file, and then we can just say Docker Compose up, and it's going to bring up all of our containers. So we're going to take a look at Docker Compose in the next video and see how we can get that set up. All right, so we're going to learn about how we can use Docker Compose to automatically spin up our containers with the desired configuration. And you're going to see that it's so much easier to use Docker Compose than just running Docker run whenever you need to, because we can spin up multiple containers all with one command, and we can also tear them down all with one command. And to use Docker Compose, we have to provide the set of instructions using a file called docker-compose.yml. And so this is a YAML file. And if you don't know too much about YAML, It's just I guess it's technically like a markup language, I guess. But the most important thing to understand is that spacing matters. So this is kind of like Python, where you need to make sure that the tabs and the spaces are just right and everything lines up, or then it's going to start to throw errors. And the first thing that we need to do is specify what version of Docker Compose we want to use. So we say version, and I'm going to say just version 3. It's not the latest, it's just kind of the most common one. If you actually go to the Docker documentation for Compose file, you'll see the different versions that you can specify, and you can actually take a look at the documentation and see what feature was introduced in what version, so you can figure out what version you need to perform all of your operations. We're not doing anything special, so version 3 is just fine for us. Then within Docker Compose, we have a concept of services. And so a service, really, at the heart of it, is nothing more than just a container. So if you want Docker Compose to spin you up a container, you have to define a service. If you want Docker Compose to spin up 4 containers, we're going to have 4 different services. Pretty simple. So we have to give each service or each container a name. So we're going to have one container for our fast API. And I'm just going to call this container API, or this service API. And the first thing that we need to do is we have to specify either the image that we use. So I could technically say like image, and then we can point to like the Python image, or I can specify build, where we can essentially do the same thing that we did before in the previous video, where we ran docker build and then provided the location of the Docker file. But we could just specify that here within Docker Compose, so that Docker Compose will automatically build the image for us if it doesn't exist. So we'll say docker build, and then we specify the context or the path to the Docker file, which is the current directory, based off of where the Docker Compose is. So they're in the same directory. So I just say current directory. And then we have to specify a port that we want to open up, because this is an API. So the outside world needs to be able to reach our container. But by default, all containers can't talk to by default, the outside world can't actually talk to your container. So we have to open up or poke holes on our local machine to open up some ports. So we say ports, and this expects an array of ports. And so there's 2 different ways to do an array. With YAML or with a Docker Compose file, we can do, just an array like this, where we just provide a list of things. Or we can also do it like this, where we do a dash and then provide, something, and then a dash for the next entry in the list. So I'm going to use this syntax because I kind of like it better. But to open a port, there's a specific format that we're going to use. So what we say is there's going to be 2 numbers. There's going to be the port on local host, and then we do that, and then we do the port on container. All right, so what's essentially happening is we're telling Docker, if we receive traffic on our local host on this port specified here, we're going to forward it to this specific port on the container. So the second number is a little bit easier to set up, because it's going to be whatever port our application's running on. So if we take a look at our Docker file, we can see that our container is going to be listening on port 8000. So we want to set this second number to be port 8000. And keep in mind, you could choose to use any other value. So if you decided to use port 80 here, then you would just change it to port 80 here. But I'm going to leave it as 8000 just for simplicity's sake. Then the second number that we're going to use is going to be the port on the local machine, or on the local host, which in this case is my Windows machine. But if it's on like a production server, it's going to be whatever machine or IP of that specific server is. And so here we could specify any port. So you can literally pick any port that's open. So if I said port 4000, what that means is that, if I go to my my Postman, this would be the equivalent of doing localhost colon 4000, right? Which is that first number. And so anytime we send traffic to that specific port on a local machine, it's going to route it to port 8000 in our container, which is what port our application's listening on. But if I change this to port 8000 as well, then our request would be localhost port 8000. So I always like to have the 2 numbers match up because it's just simpler, but sometimes that's not an option. So just pick a open port on your localhost machine. It doesn't really matter what it is. Just make sure that you remember what it is. And I'm going to leave it like that, and I'll delete this line right here. And for now, I think this is good enough. And what we're going to do is we're going to try to run this and see what happens. So I'll say docker-compose up. And then if I do a --help, we can see some other flags that we may need. And the only flag that I really need right now is the -d. So this is going to run the containers in the background so that we're not automatically connected to it. So I'll do just -d. Right. And so you'll see if you take a look, what's happening is we're rebuilding our image. So because we specified the build right here, it's going to build our image. And then it's going to start our containers. So you can see that it's creating fast API underscore API underscore 1. And so the naming syntax comes from the project directory. So it's called fast API, right? So that's why the first word. Then we do underscore. Then the name of the service. So I called this service API. So then it's API. And then it has the number 1 because there's one instance. But if I told it to spin up 4, then I'd have 1, 2, 3, and 4. So we've got our container. If I do a Docker PS, we should be able to see. Nope. Oh, we can see it's down. And that's because if I do a Docker PS-A, and we can see that this one right here looks like it stopped 43 seconds ago. And so it crashed for whatever reason, and that's okay. What we can do is, I think we can actually see the logs after it goes down. So if I do Docker logs fast API 1, we can actually take a look at the logs at what caused it to go down. And we can see a couple things, but we can see that we get the Pydantic error for our settings object, which is all of our environment variables. So obviously a container is like its own separate machine. So it needs all of the environment variables passed to it, or then our application is going to crash. So how do we pass an environment variable in Docker? Pretty simple. We just pass a environment field. And then here it's going to provide, you need to provide an array of environment variables. So I do dash. And then here we just specify our environment variable. So I'm actually going to copy and paste this section right here. And so these are all of our environment variables. Keep in mind, if you don't want to actually write out all of your environment variables, we can actually use Docker to point to a .env file or a environment file on your local machine. And if you want to do that, it's pretty simple. Here we would just specify the env underscore file. And then you can actually provide multiple files, but in this case, you just provide the path to the file. So it's going to be in the current directory, and it's going to be .env. So you can do either one or a combination of both. I'm just going to use this format so that we can see all of the environment variables, and I'm going to just comment this out for now, just for documentation purposes. And now what we're going to do is we're going to do a Docker compose down just to tear everything down. And I'm going to bring it back up in detached. And notice this time it didn't build the image. So why exactly didn't it build the image? Well, Docker Compose is very simple. All it does is it goes to Docker image, basically just runs a Docker image ls, and it looks for the image that it would have created. And there's a very specific format that it uses, which is going to be the name of the folder or the directory, and then underscore, and then the service. So since the image was already created previously, it doesn't recreate it. However, if you obviously make changes to your Docker file and you want to make changes, then you would have to do Docker up. And then if you look for the flags, there should be a let's see, build. This is going to force it to build a new image. So keep in mind, anytime the image has to change, and but the image already exists, then you have to pass in that flag to force Docker Compose to let it know that, hey, I made some changes. I need you to rebuild it for me, because Docker Compose can't detect that. All right, so now if we do a Docker PS, we can see that it's running now and it didn't crash. And we should be able to access it on port 8000. So if I actually go here and just do localhost 8000 with the GET request, looks like it's working. Okay, so now that we can actually access our API, which is running in a container, the next thing that I want to do is I want to set up our Postgres database. And you might be thinking, well, we already have one installed on our local machine. Why are we setting up another one? Well, a couple things. First of all, if we're already Dockerizing our environment, it makes sense to set up our Postgres database, especially from a development perspective within a Docker container, because it's so much easier to set up a database in a container than it is to install it on our local machine, because we just spin up a pre-built image and that's it. So even if you don't actually want to Dockerize your application, from a development perspective, I strongly recommend you make use of Docker containers so that you can spin up a quick database just for testing purposes. But since we already have a Docker-based application now, we're going to just use a Postgres database that's running in a Docker container instead of on our local machine. Because if we take a look at the environment variables that we pass to our container, we provide a value of localhost. And so localhost means that the container is going to, or the API running in the container is going to try to access a database running locally on that container, which it's not. So let's create a brand new service, which once again is nothing more than another container for running our Postgres database. And so I'm going to go down here and we're going to create another service called Postgres. And here we're going to provide a image flag, right? Because here we did build because we're building a custom image. Here we're going to use the pre-built default Postgres image. So if we go back to Docker Hub and search for Postgres, you'll see this is the official Postgres image. And this is going to contain all of the documentation for setting up Postgres. But the main thing is there's a couple of environment variables that we have to pass. So first of all, the password that's going to be used for our database. We can give an optional Postgres user, but it's going to default to Postgres if we don't provide it. And then we also want to give it a Postgres database name. So we'll call it Fast API like we've been using in our development environment. And that should be all that we have to do for the most part. So here I'll say environment. And we'll do Postgres _ password equals, and then we can give this anything we want. So password 123. And then we want Postgres _ DB. So this is going to be Fast API. All right. The next thing that we want to do is when it comes to data within a container, that data doesn't persist as soon as the container goes down. Right. So when you delete the container, you lose all of your data. All right. And so from a database perspective, we don't actually want to lose our data. We want that to persist even if we kill off the container. So how do we actually save that data? We have to create something that's called a volume. And that's what allows us to save data from a container onto our local machine so that if we kill the container, we can always spin up a new container and just point it to those files. And there's a couple of different volumes that we can use, or types of volumes in Docker. There's anonymous volumes, named volumes, and I think bind mounts is the other one. We're going to make use of named volumes. And so to create a named volume, here under the Postgres database section or service, we're going to say volumes. And then we say dash, and then provide a name for the volume. So you call it whatever you want. I'm going to call this Postgres-DB. Right? And then we have to specify the path in the container that we want to actually save. So what directory do we want to persist on our local machine? And the path that the Postgres container or image actually stores all of its data, we can actually take a look at the documentation to figure this out. So if you search for volume, and so right here, this gives us an example, and this is going to tell us what we need to know. So we want to save /var/lib PostgreSQL/data. So that's where it's going to save all that data. So we'll copy that. And once again, this is the path in the container that Postgres is going to write to. So that's where all of our tables, all of the entries are going to get stored. So we want to copy that essentially and save it on our local machine. And the last thing that we want to do is anytime you use named volumes, we have to create another volume section globally and then just pass the name that we created. So whatever is here, you just put it down here. And the reason we have to do this is because named volumes are designed so that technically multiple containers can access them. So you define it down here first technically, and then multiple containers can reference them by just calling that. All right, so we've got this set up, and actually I realized I left my containers running. So what I'm going to do is I'm going to comment this out for a second, save this, and I'm going to do a Docker compose down. So it's going to delete everything. Then we'll uncomment our Postgres service. Then the next thing that we want to do is we have to figure out, what is the host name, or what's the IP address of our Postgres database. And, there's a couple of different ways to do that. But what's awesome about Docker is when you use Docker Compose, it creates a custom network. And a Docker network uses DNS. So we can actually say to reach the Postgres database, instead of looking for the IP address of that container, we can use DNS, and I can just say, if I try to reach the name Postgres, right, it's automatically going to resolve to our Postgres service. So whatever our service is called, we can just reference that. And this is going to allow this container to know that when you want to talk to the Postgres database, this name here is going to resolve to the IP address of this container. And so networking with Docker within Docker is so simple because that's all we have to do. And then the rest of the things, the default port, the password, the database name, the database username, those should all be okay. And we can just leave as default. And now I can then start this up. And it looks like image, something's wrong with the image. I forgot to give the image. So what's the image name? It's just Postgres. So that's just whatever this name is. That's all you need. All right. And so now we can see that it started up both. Let's just quickly test our API so we didn't break anything. So that works. And then let's go to create user, make sure it's point to port 8000 in this case. And if we create user, right, you can see that we have successfully created the user. So it looks like we can now access the database from our Fast API container. Now, what I'm going to do now is delete everything again. So Docker Compose down deletes everything. And you can see I'm essentially able to destroy both of my containers with a single command. And that's kind of the power behind Docker Compose. And ideally, we want our Postgres container to start up first because our API is dependent on the container. So for our API, we can pass in another option. And I can say depends on. And here we can specify a list of services, in this case, just Postgres. And so this is going to tell Docker, I want you to start the Postgres container before the API container starts. Now, technically, it's not going to wait for Postgres to actually fully initialize. It'll just start the container. So you still want to put in checks in your code to make sure that, if you can't access the database because it's not initialized, you want to keep retrying. And so once again, we can bring this back up with a single command. And if you take a look at the order, you can see that we started up the database first. So now you'll always start up your database first and then start up Fast API. And then you'll stop Fast API first before stopping the database, because we set up the depends on. When it comes to working with Docker containers, we do experience a few extra challenges, especially from a development perspective. And I'm going to show you how those challenges actually work, or what those challenges actually are. And if I actually go back to my test request, wherever that is, where I'm just going to reach the default URL. So if I hit send, you can see it says hello world pushing out to Ubuntu, right? And that's because in my main.py file, it just says hello world pushing out to Ubuntu. Now, if I save this or change this and then save this, and then I send a request, right? We still get the same response. I don't get the new text that I added. So why is that? Well, there's a couple things that are happening, but the easiest way to figure this out is to actually poke around in your container and figure out what's happening. So I'm going to do Docker PS, and I want to see what the file system of Fast API container actually looks like. So to do that, we do Docker exec-it. So that's going to enter into interactive mode. We specify the container name, and then we type in the word bash. So what we're doing is we're entering interactive mode, and we're going to override the default command of the container. So the default command is specified right here from the Docker file. So we don't want to run that. We just want to run bash, which is going to allow us to access the file system. That's the image name. So the name of the container is fastapi_1. So let me add the 1. So now you can see that we get a Linux prompt. So we're in the Linux file system. And if I go into app and then go into, if I do cat, which is going to print out the contents of a file, we'll take a look at the main.py file. And you can see that it just says hello world pushing out to Ubuntu. So when I made these changes and added these extra characters, it didn't get pushed out to our container. And if you're trying to figure out why that is, it's pretty obvious, right? Because what we did was we created an image which copied all of our code here at that point in time. And then when we did a Docker Compose up, it created the image, and then that was it, right? Nothing else changes, right? Afterwards, we went in and changed the code, but the image was already created. So whatever's in the image, nothing changes after that point. So any changes we make will not get copied over to our container. So what do we do in this case? How do we get around this limitation? Well, what we can do is we can make use of a special volume called bind mount. And a bind mount is a special volume because it allows us to sync a folder on our local machine with a folder in our container. So this app folder which has all of our application code, what we want to do is we want to sync this folder in our container with this folder here so that if any changes get made here, it's going to get copied over to our container. And so under volumes in our API, we're going to define a volume here. And I'll say volumes, right? Just like we did with Postgres, very similar, except we're going to use a different syntax because this is a bind mount. So a bind mount, we have to first provide the path of the folder that we want to sync on our local machine. So this is our current directory. So we can just do / for current directory. But if you wanted to sync just one individual folder, maybe like the app folder, then you can do /app. Up to you, but I'm going to sync everything. And then we have to specify the path in our Docker container, which is going to be this folder right here. And that's going to automatically sync the two folders. And if you wanted to add some extra security, you can do RO. This means read only. So what this does is this makes it so your container can't change any of these files, because only we should be changing the files, not the container itself. So this just adds a little bit of extra security if you wanted to, but it's still technically optional.